Hi friends, today we're going to put kind of everything we've learned throughout this right triangle trig unit together and solve a whole triangle. Our learning target, I can find all the missing parts of a right triangle using trigonometric functions. Our standard, again, apply the trig ratio, sine, cosine, and tangent to solve problems, and then know how to use calculators, tables, or other technology to evaluate trig ratios. So recall here to solve for an angle. This is what we did day 3. But we use the inverse functions. So we have hypotenuse, opposite, and adjacent. We know the hypotenuse and the opposite, so we're going to be using sine. Sine of x is opposite over hypotenuse, so 10/12. And then we do the inverse sine on both sides. So inverse sine of sine x equals inverse sine of 10/12. And then the signs cancel. So we're left with x on the left side. And then the right side, if we put that in our calculator and round to the nearest hundredth, 56.44 degrees. Remember, when we're solving for an angle, we need the degree symbol. And I know I'm solving for an angle because it's inside here. This one's solving for a side when you know 2 of the sides. Since we know 2 of the sides and this is a right triangle, I can just use the Pythagorean theorem. A squared plus b squared is c squared. Remember, c has to be across from the right angle, so that x has to be c, and then a and b don't matter. I'm going to call 3a and 4b. So 3 squared plus 4 squared is x squared. 3 squared plus 4 squared is 25. So 25 is x squared. And then to undo that squared, we'll square root both sides. And 5 inches is x. Remember to label. If there's a label in the problem, there should be a label in your answer. That's if you know 2 sides. Here, we need to solve for this last angle. I know this angle is 90 degrees. Recall a triangle has to add up to 180. So 56 plus 90 plus x is 180. 56 plus 90 is 146. So 146 plus x is 180. And then taking 146 from both sides, I would get that x is 34 degrees. So we're going to use all of that to solve for all missing parts of a triangle. So if you look here, we're missing angle A, we're missing side BC, and we're missing side AC. I'm going to call BC X and AC Y. It really doesn't matter what you call them. And then I'm just going to call my angle, we'll just leave it as angle A. So the order that you do this is up to you. Generally, if you're given one of the angles along with the right angle, to find the third angle is pretty easy. So let's do that one first. The measure of angle A. Again, I know that 42 plus 90 plus A is equal to 180. 42 plus 90 is 132. So 132 plus A is 180. And then taking 132 from both sides, I would get that A is 48. So the measure of angle A is 48 degrees. Again, every time we have an angle, we'll have a degree symbol. So now I know this is 48 degrees. Now I need to find BC and AC, or on my picture I labeled them X and Y. It's up to you which one you find first. It's up to you if you use 42 degrees or 48 degrees as your reference angle. I'm going to have my reference angle be 42, and I'm going to solve for X first. So I know that Y is my hypotenuse, 8 is my opposite, X is my adjacent. Again, that's only because 42 is my reference angle. If I chose to use 48 degrees, then my adjacent and opposite would be switched. Solving for X, so I'm solving for my adjacent, and I know my opposite, which means I'm going to be using tangent. So for BC, I'm going to say tangent of 42 is opposite over adjacent, so 8 over x. And then solving this, we'll start by multiplying both sides by x. X times tangent of 42 equals 8. And then dividing by tangent of 42 to get x by itself. Tangent of 42 gets canceled. So then x is 8 divided by tangent of 42, which will give us about 8.88. So that's BC, 8.88 feet. And now we need to find AC. I'm going to make these a little smaller. AC in this case is my y. When we know two sides, it's up to you. You can either use the Pythagorean theorem or you can use trig again. Okay? So I could say, so again, two options. I could say, now I know this side is 8.88. So option number one, Pythagorean theorem, 8.88 squared plus 8 squared is y squared. So that's option number one. You can solve that, and you'll end up rounding your answer, which is fine. Or option number two, I could use sine and say sine of 42 is opposite over hypotenuse, so 8 over y. Either one of those would work to solve for AC. Regardless of which one of those you choose to use, you should get that y is about 11.96 feet. So again, solving for the third side, it's kind of up to you which method you prefer. If you like Pythagorean theorem, then use Pythagorean theorem. If you like using trig, then use trig. But you can only use Pythagorean theorem if you know two of the other sides. Let's look at another one. So we need to find measure of angle S, measure of angle Q, and SQ. So I'm going to put an X here for SQ. Again, the order that you do that is up to you. I'm going to start with the measure of angle S. If S is my reference angle, then X is my hypotenuse, 6 is my opposite, and 10 is my adjacent. Since I know 6 and 10 are my opposite and adjacent, I'm going to be using tangent. So tangent of angle S is 6 over 10. And then to solve this, we would do inverse tangent on both sides. So S then would be inverse tangent of 6/10. And if I did inverse tangent of 6/10 in my calculator, I would get that S is about 30.96. So my first angle is 30.96 degrees. Then I'm going to go ahead and solve for my second angle. Probably the easiest part is solving for the last angle of the triangle. Because now I know that these three angles need to add to 180 degrees. So Q plus 30.96 plus 90, don't forget your 90-degree angle, is 180. Simplifying here, 30.96 plus 90 is 120.96 equals 180. And then taking 120.96 from both sides, I would get that Q is equal to 59.04. So 59.04 degrees. And then again, for the third side, you have an option of whether you want to use the Pythagorean theorem. So side SQ, you could use the Pythagorean theorem. You're solving for the hypotenuse, so it would be 10 squared plus 6 squared is x squared. That's option 1. Or we could use one of our angles and use trig. If you wanted, there's many different ways that you could set up if you wanted to use trig. Some options would be sine of 30.96 equals 6 over x. That's one option. Or you could say cosine of 59.04 is equal to 6 over x. That's another option. Or, I'm going to run out of space here. We could use cosine of 30.96 equals 10 over x, or sine of 59.04 equals 10 over x. Any of those 4 ways would work, or the Pythagorean theorem. So again, you have 1, 2, 3, 4, 5 different options to solve for that last side. It's really up to you which option you prefer. One is not necessarily better than the other. It's just what you're more comfortable with. I wouldn't switch back and forth, though. I would pick a method, either Pythagorean theorem or trig, and always use that method. Regardless of which one you choose, you should get that the last side is about 11.66 feet. Now, depending on if you use trig or Pythagorean theorem and how you round, you might not get exactly 11.66, but you should get something close to that. Let's look at another one here. It looks like we're looking for 2 angles and a side. We'll call that side X. I'm going to find my side first, and I'm going to use the Pythagorean theorem. So using Pythagorean theorem, x squared plus 5 squared is 5.7 squared. So x squared plus 25 is 32.49. Taking 25 from both sides, I would get that x squared is 7.49. And then finally, square rooting to get x by itself, I would get that it's about 2.74. So that's my first one that I found. Now we need to find the angles. One of them will use trig, and then the other angle will use the fact that it adds up to 180. It's up to you whether you want to find T or R first. I'm going to use R. So if R is my reference angle, 5.7 is my hypotenuse, 2.74 is my opposite, and 5 is my adjacent. I'm just going to use the sides that they give me. So I'm going to use hypotenuse and adjacent. So for angle R, hypotenuse and adjacent is cosine. So cosine of R is 5 over 5.7, which means R is going to be inverse cosine of 5 over 5.7. And if you put that in your calculator, you would get that R, after we round, is 28.69. So R is 28.69 degrees. And then again, remember, this is 90. So for angle T, I know that they all have to add to 180. So 90, 28.69, and T have to add to 180. 90 plus 28.69 is equal to 118.69 plus T is equal to 180. And then taking 118.69 from both sides, I would get that the measure of angle T is equal to 61.31 degrees. Ran out of space a little bit on that one. Let's look at two more here. So we have to find the measure of angle B. We have to find CB, which I'm going to call X, and AB, which I'm going to call Y. You can call them anything you want. You can leave them as CB and AB. It's up to you. So first, for the measure of angle B, I know that these three angles need to add to 180. So 90 and 41.8, and angle B has to be 180. 90 plus 41.8 is 131.8, plus B is 180. And then taking 131.8 from each side, I would get that B is 48.2. So B is 48.2 degrees. Now we need to find our two sides. I'm going to find CB first, which in my case is my X. I'm going to use 41.8 as my reference angle, which means X is opposite and 10 is adjacent. So tangent. Tangent of 41.8 is X over 10. Getting X by itself, we'll multiply both sides by 10. So X is equal to 10 times tangent 41.8. And 10 times tangent 41.8 gives us 8.94. So CB here is 8.94. Make sure you keep yourself organized as you're doing this. AB then, again, you could use Pythagorean theorem, or you could use trig. If we use Pythagorean theorem, I would do 10 squared plus 8.94 squared is y squared, and solve that. If you wanted to use trig instead, you could. The options for trig, if we're using 41.8 as our reference angle, we're looking for the hypotenuse. So you could either do sine of 41.8 equals, not x, equals opposite over hypotenuse, so 8.94 over y, or you could use cosine of 41.8, which is adjacent over hypotenuse, equals 10 over y. Regardless of any of these three ways that you used, you should get that y, or AB, is 13.41. You might get slightly different depending on which method you use, but they should all be very close to 13.41. All right, let's look at one more. We need to find measure of angle A. We need to find AB and AC. I'm going to find measure of angle A first. That's the easiest. I know 90 plus 43 plus angle A is equal to 180. 90 and 43 is 133. Plus angle A is 180. And then if I take 133 from both sides, I would get angle A is 47. So 47 degrees. Now I need to solve for X or Y. I'm going to solve for X first, just because I think Pythagorean theorem is easier when you're looking for the hypotenuse. So 43 is my reference angle, x is my opposite, 6 is my adjacent. So I'm using tangent. Tangent of 43 is x over 6. Getting x by itself, we'll multiply both sides by 6. Those 6's go away. And 6 times the tangent of 43 is 5.59. So here my x would be 5.59, and x is AC. Make sure you write it in the correct place. Let's divide these. Those are two different parts. And then my last part, finding y. Again, I'm going to use Pythagorean theorem, but you could also use trig. Pythagorean theorem, 6 squared plus 5.59 squared is y squared. So that's one option. Or if we're going to continue to use 43 as our reference angle, another option would be sine of 43 equals 5.59 over y, or cosine of 43 equals 6 over y. Any of those three would work. Regardless, you should get that y, or AB, is equal to 8.20. All right, friends. So again, a method you could use to kind of organize yourself is do whichever one is easiest first and then work your way out. If I'm looking for an angle and I already know one of the angles, I always do that first. If I'm looking for two different sides, I usually leave the hypotenuse for last because it's easiest for me to use the Pythagorean theorem, or again, you could use right triangle trig in order to solve for that last side.